Greetings, welcome to a video on exercise 3.25, underage drinking part 1. Data collected by the Substance Abuse and Mental Health Services Administration suggests that 69.7% of 18 to 20-year-olds consume alcoholic beverages in 2008. Suppose a random sample of 10 18 to 20-year-olds was taken. Is the use of the binomial distribution appropriate for calculating the probability that exactly 6 consume alcoholic beverages? Explain. Okay, so what we need is we need to come in and verify the 4 things to determine whether or not a binomial experiment is being conducted, and thereby we can use the binomial distribution. So the first one is, do we have independent trials? And the answer here is yes. We'll go ahead and just come in and write yes or check on this. Why? Well, because knowing whether the alcohol drinking status of one 18 to 20-year-old is not going to tell you anything about the next one, because what? They used a random sample, right? And what that means is they didn't do, all 10 of them from the same frat house, right? Or the same high school or the same whatever, okay? All right, fixed number of trials. Yes, our fixed number of trials here, n was equal to 10, so there were 10 trials only. Only 2 possible outcomes in each of the trials. Again, yes, either they drink or they don't drink, right? So it's either drink or not, okay? And the probability of success remains fixed. So I'm assuming that this is a rather large population that we're sampling from, so that probability of success is going to remain fixed because we have a very small sample, only of size 10. And so our probability of success here, P, that was given to be 69.7%. Or as a decimal, that would be equal to what? 0.697, correct? Okay, cool. So let's go answer some questions about this particular binomial. In other words, let's go calculate the probability of exactly 6 out of the 10 randomly sampled 18 to 10-year-olds consumed alcohol, round it to 4 decimal places. Okay, so to do this calculation, what I highly recommend that you do is you go in, stay with the blue pen, will be just fine. As you go in, first of all, and write down what they ask you to do. So they want to find out is this. They want the probability of x being equal to 6. Really important you start off with that, because what that tells me is that I'm looking for just a particular value in this distribution. In a discrete distribution, it makes sense to talk about a particular outcome. A particular outcome of the random variable, a single outcome of it versus an interval. So the next thing we do is let's write down the model we're going to use. We know that it's binomial. We know that its binomial will go n by p. In our particular case, it's binomial with n being 10 and probability of success 0.697. Okay? All right, and then I always strongly recommend that you draw a number line that represents the situation here. So we have what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it's basically 0 through n is what your number line should contain. And it's always going to be in whole number increments, okay? So all we're looking for here is just this single probability. So I'm just going to put a dot over the top of it right there. That is a visual representation of the probability of x equals to 6. Okay, now I'm going to get my calculator out to actually do that calculation. So this is going to be Bino PDF. And one way of thinking about that is that if you think about the P here is being for particular. In other words, it's a single value. We're not doing multiple values. We're not doing an interval. We're doing just a single value of the random variable, okay? And the calculator wants to know what n is, it wants to know what p is, and it wants to know what x is. So you got to give it in that order. Now in the new fancy ones, it's got a menu-driven thing where you can enter in those things and it'll paste the command together for you. But on the older ones, you're actually going to have to type them in and make sure you get the numbers in the right order in here, or it won't work. Okay, you got to put them all in there. So for our particular problem, that's going to be Bino PDF, where n is going to be 10, probability of success is going to be 0.697, and our x is equal to 6. Okay, so let's go ahead and get that calculator out here. So let's get that up here for you. Lots of things running at the moment. Okay, so let's go ahead and input that into our calculator. So let's clear out our last problem that we did. We're going to go second, distributions. All of our probability distributions that we're going to be using live in this menu. You can scroll down if you want, but it's actually faster if you scroll up. It wraps back around because it's going to be option A here. It's down near the bottom. Okay, so grab Bino PDF. So this is on a newer calculator. It's going to be menu driven, so it wants to know the number of trials. Well, we determined that in problem 1. That's 10. Probability of success is 0.697. Those kids drinking alcohol at a young age, I tell you. And we want to know what's the probability of seeing 6 out of the 10, exactly 6 out of the 10 that consumed alcohol. And then we go paste. And notice that what it did is it came in and it constructed this exact same command that I have written down here, okay? Hit an enter. And they asked us in this problem, they wanted us to round off our solutions to 4 decimal places here in part B. So rounding off to 4 decimal places, that would say, let's go grab our pen again, that's going to be equal to 0.2095, rounding off correctly. Don't forget that right here, you're going to round off to a 5 because the digit past where you're rounding to, your test digit is bigger than 5. Okay, cool. Alrighty, so that takes care of that one. Let's move on. Let's get a clean piece of paper here. Okay, so what would be the next problem they want from us? Well, they say, what is the probability that exactly 4 out of the 10 18-year-olds have not, and this is very important, make sure you're paying attention, have not consumed alcoholic beverages, okay? So notice they're changing that on us. So have not consumed alcoholic beverages. So in a sense, you can think they've changed. There's a couple different ways of thinking about this, but probably one of the easiest ways of doing it is that they've now asked us to find the probability of failure, okay? Or use the probability of failure, I should say, because this time we're saying a success is somebody who does not consume alcohol. So our distribution, our model that we're going to use has changed because of that, okay? So let's go back and clean up my mess here. Let's go back and set up the new problem. So now the binomial model that we're going to use this time is going to be, again, n by p, but this time the probability of success, well, it's going to be still 10. They still have an n of 10, but p, how do we calculate p? Well, let's go grab our calculator here for a moment. To get p this time, I'm going to take 1 subtract 0.697. In other words, I'll use the probability of failure from the first problem, which is 0.303. So 0.303 is the model we're using this time. Okay, so same thing, start off with a number line. It's got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These will become more valuable as we move through these. Just get in the habit of doing them all the time. These are X's. These are the number of successes out of 10 trials. Otherwise, we saw 0 of them did not drink, 1 of them did not drink, 2 of them did not drink, 3, etc. Each one of those counts for the number of them that did not drink. Okay, so what are we going to calculate? Well, we're going to go Bino PDF. Our n was 10. Our probability of success this time is 0.303, and the number was 4. Okay? Alrighty, so let's go grab our calculator. Let's go ahead and plug that in. So go second, distributions, go Bino PDF. It's option A here, and we can also get it by going alpha A if you want to. That works too. So notice the only things that I need to change here are the P and the X. So I'm going to put in 0.303. And then let's put in the X is going to be equal to 4. Paste that in and, look at that. We got the same answer that we did last time, okay? Why did that happen? Why did we get the same number? Uh, 2029. Actually, I think we only needed to round off there. I went to 5 last time, and that was we only needed to go out 4 places. Okay, so you actually didn't need the 5 on that last one. Sorry about that. Okay, so Why did we end up with 4 on this one? Because, well, if you think about it, if you'd come the other direction, 0, 1, 2, 3, 4, you would have landed here, wouldn't you? Okay? So in other words, we basically flipped this distribution on its head, and we counted up 4 from 0, or counted down 4 from 10 to get back over to the 6, okay? So they're basically the same probabilities, just looked at from different angles. All right, let's go on to the next one. Our next problem that they have for us. Let's go ahead and clean off get ourselves a fresh piece of paper here. What's the probability of at most 2 out of 5 randomly sampled 18 to 20-year-olds have consumed alcoholic beverage? Please round your answer to 4 decimal places again. Okay, all right, so let's go ahead and do that. So this time, notice they've changed, not the probability of success, but they've changed the sample size. Okay, so we're only going to do 5 this time, but probability of success is going to remain the same, okay? So we want the 2 out of 5 will have consumed alcoholic beverages, okay? All right, so our new model is binomial 5 by 0.697, okay? In other words, our n is 5 now, but our probability of success has remained the same. And what they want to know is what is the probability of at most 2. All right, let's go ahead and do that number line again. That is going to really make things a lot easier to see what they're asking for here. So it's 0, 1, 2, 3, 4, and 5. In other words, this is my x line here. These are the values the random variable can take on. Remember, it's counting the number of successes out of 5 trials, okay? So at most 2. So that means 0 is part of it, it means 1 is part of it, and it means 2 is part of it. In other words, 0, 1, and 2 all count as at most 2. So it's up to and including 2. So how do we calculate that probability? Well, there's a couple of different ways we could do it. You could come in and go, okay, this is the probability of x being equal to 0, plus the probability of x being equal to 1, plus the probability of x being equal to 2. And I could go in and use Bino PDF for each one of these and then add the 3 numbers together. But one would think that those smart folks at Texas Instruments have come up with a way of doing that on its own, and yes, they have. You would use, in this case, use Bino CDF. And you can think about the C here. Remember, we thought the P was for a particular value. The C actually, think about it, really is. It means cumulative. It means you're adding them all up, okay? So that means it means sum up the probabilities up to a particular point. All right, so what do we got to give Bino CDF? Well, we've got to do what we did on the previous on PDF. We've got to give it n, we've got to give it p, and we've got to give it x. But this time x takes on a different meaning. What x is this the farthest number to the right. It means tell me how many numbers you want to add up, starting at the left and working up to the right. So be careful with this because it only sums from the left. So the x is going to be the right endpoint. So it's the right endpoint, and you're going to sum up to that point. Okay, now that works out perfect here because it's exactly what we want it to do. So for our problem, we're going to say, okay, Bino CDF, our n is 5, our p is 0.697, and our x in this case is 2. Okay? All right, so let's go ahead and get the calculator. Calculator, where are you? There you are. Okay, all right, let's clear out get rid of all this crazy stuff. So we're going to go second distribution, and we see Bino CDF is option B in the menu of distributions. So grab Bino CDF. Number of trials this time was 5. Probability of success was 0.697. The x value in this case is 2. Okay, so paste that command in there, and we get back 1.671. Remember, you got to round off to 4 places. Okay, so make sure you do the rounding correctly. It's not very forgiving if you don't do that. All right. So, by the way, if that happens to you, if you round off incorrectly, do let me know. I'm very good about, I have a heart. I will not make you redo the whole problem just because you rounded off incorrectly, okay? You'll get a nasty gram from me telling you, remember how to round off, but I'm not going to make you redo the whole problem, okay? We're trying to learn statistics, not arithmetic. Okay, cool. All right, we got one more problem in this problem set to take on. Let's go ahead and do that. So let's get ourselves a fresh piece of paper here. Here we go. Okay, so part underage drinking is still part 1, but this is part E of that problem. It says, what is the probability that at least 1 out of 5 randomly selected 18 to 20-year-olds have consumed alcoholic beverages? Please round to 4 decimal places. So this is at least 1, the infamous at least 1 problem, okay? So what they want to know, let's go ahead and put our model down again. So this is Bino 5 by 0.697. Probably not a bad idea to have that leading 0 there, huh? Okay, and they want to know the probability of at least 1. All right, again, let's do a number line that describes the situation here. So we've got 0, 1, 2, 3, 4, and 5, okay? So those are the possible values a random variable x can take on. So at least 1, well, that means 1 would work, 2 would work, 3 would work, 4 would work, or 5 would work. Okay, so now notice what that means is that I would have to come in and go the probability of x is equal to 1 plus the probability of x is equal to 2 plus dot 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 plus the probability of x is equal to 5, right? I have to add them all up. The dot 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 means there's a 3 and the 4, everybody, okay? Now notice the only one that I didn't put in this sum was 0. Remember, when if I add them all together, right? If I add all of these together, they have to add up to 1, don't they, right? So let's throw 0 in there. So if I add in the probability of x being equal to 0, notice that this whole shenanigans here has to sum up to 1, right? Whereas I've got all of them then. In other words, if I threw in, let's color in red here, if I threw in the 0, right? If I add up all those probabilities, they've got to sum to 1. Okay, so a quick way of doing this probability, instead of calculating all the blue ones, all I'm going to need to do is come in and go, well, look, I know the probability of x being equal to 1 plus the probability of x being equal to 2 plus dot 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 plus the probability of x being equal to 5 is going to be equal to 1 minus the probability of x equal to 0. In other words, subtract that x equal to 0 probability from both sides of that previous equation. And so notice then that this, in the green box, is what I need to do. In other words, that probability right there, subtract it from 1, and it'll give me the probability of all the rest of them. And that's the trick of the at least 1, is that you basically take the probability of 0 and subtract that from 1, and that will always give you the probability of at least 1. Okay, so how does that look on the calculator? What would we do to do that? Well, notice it's only a particular value, so we're going to use PDF this time. So I'm going to go ahead of myself here. I'm going to take 1, and I'm going to subtract this from this. Bino PDF. See, my n was what? 5. My probability of success was 0.697, and my particular value was 0. Alrighty then. Whew. Let's go get that calculator out, and let's do this. Okay, so clear out the home screen, and I'm going to put in 1, subtract, and go second, distributions, Bino PDF. Up here, that's option A. Put in the trials as 5. Probability of success is 0.697. My x value is 0. Paste that command, and notice it looks just like what I have written down, okay? I strongly recommend you write down onto paper what you're going to type into the calculator before you type it in. It helps get rid of the cognitive load. If you're trying to push the keys and find the menus and all that stuff at the same time we're trying to build the command, it can really drive you crazy, okay? So build the command on paper first, then type it into the calculator. Hit an enter, and we get back 0.9974 if we round off correctly. So let's get my pencil back open here again. So that's equal to 0.9974. Okay, well, I hope you found this video useful. Binomial probabilities by no means are easy the first time you see them, but once you get the hang of them, they're actually pretty straightforward, okay? So keep working these problems and send me help questions or requests for help if you need it.